Imagine a place colder than deep space, colder than the darkest corner of the universe. A place so cold that motion itself almost disappears. Now imagine the opposite. A temperature so extreme that atoms explode, nuclei dissolve, and matter itself stops being matter. Here's the strange part. Physics says there is a lowest possible temperature, but it doesn't clearly say there's a highest one. Why would reality have a floor, but maybe no ceiling? Today, we are uncovering one of the most fascinating asymmetries in the universe. To solve this mystery, we need to understand what temperature actually is. Temperature is not a feeling. It's not hot or cold. Temperature is motion. More precisely, temperature measures the average kinetic energy of particles. Every atom around you is vibrating. Even the air you are breathing. Even the atoms inside your body. The faster they move, the hotter something is. The slower they move, the colder it is. So temperature is really just a measurement of how much particles are moving. And this is where the mystery begins to crack. Let's cool something down. As we remove energy, particles move slower, vibrations decrease, and motion weakens. Lower temperature simply means less movement. But here's the key idea. Particles cannot be more stopped than stopped. Think about that. You can slow motion down, you can reduce speed, but once something reaches zero movement, you can't go below zero movement. There is no such thing as negative motion. That's why there is a minimum temperature, 0 Kelvin, the absolute zero. It's minus 273 degrees Celsius. At this point, particles have the lowest energy physically possible. Motion is reduced to its minimum allowed by quantum mechanics. Even then, quantum physics tell us particles still have a tiny residual vibration, called zero-point energy. But you cannot remove more energy beyond that. You hit the floor, and that's why called as a limit. Because motion has a limit. You cannot be more still than perfectly still. Now let's go the other direction. Instead of removing energy, we add it. Particles move faster, then violently fast. At high temperatures, molecules break apart, atoms lose their electrons, nuclei themselves break down. Matter becomes plasma. Push even farther and you get something called a quark-gluon plasma. The same state that filled the universe right after the Big Bang. But here's the crucial difference. There's no equivalent of maximum motion. As long as you add energy, particles move faster. There is no obvious point where nature says this is the fastest allowed. Unlike stopping, which has a clear boundary, speeding up does not. There is no symmetrical rule saying the motion can't increase beyond some number. So heat doesn't encounter the same wall that cold does. Physicists do talk about something called the Planck temperature. It's about 100 to the power of 32 Kelvin. At that scale, gravity becomes quantum. Our current physical theories stop agreeing. The math breaks down. But this doesn't necessarily mean temperature stops there. It only means our understanding does. It's a theoretical boundary of knowledge, not necessarily a physical ceiling. Cold has a limit because motion has a limit. You cannot have less than zero movement, but heat might not have a limit because energy can, in principle, keep increasing. At the bottom, there is a floor. At the top, there might be no ceiling. And that asymmetry is built into the fabric of reality. The universe allows infinite acceleration, but not infinite stillness. You can always move faster, but you can never be more stopped than stopped. And that might be one of the deepest clues about how reality truly works. If you enjoyed this exploration into the limits of the universe, leave a like and tell me, do you think there is a truly no maximum temperature? Or is there a ceiling we haven't discovered yet? See you in the next video.